Sound, as I told you before, is an example of mechanical wave because it needs a material medium for its propagation. But in definition, we can say that sound is a kind of longitudinal wave which causes sensation to audibility. Because where there is sound, you can hear. And when this is not existing as a wave, it becomes impossible for us to hear anything. Talking about sound, which we have defined as a sensation to audibility, we can bring in the types of sound. Types of sound. 1. We have a type of sound known as noise. 2. We have another type of sound known as music or reading. First one, noise, is formed as an irregular combination of frequencies. You may have different frequencies, but the way you combine them, we said in irregular manner of combination of frequency, that produces what? Noise. While music is produced, is a kind of sound obtained by regular combination of frequency. When we have different kinds of frequency combined together regularly, we'll have what we call music or reading. While when it's irregularly combined, we said we have what we call noise. Now, there are types of musical notes which we would like to mention. First, types of musical notes. Musical notes. The first one, we have what we call fundamental notes. Fundamental notes. This is a musical note with a single frequency. Whenever there is a single frequency obtained or ascertained in a single musical note, we'll say that that particular note is fundamental, and we tagged it what? F0. That means that F0 is equal to 1F. Whenever there is one frequency, we say that that is fundamental note. We also have the second one or group called the harmonics. And we said harmonics are integral multiple of fundamental notes, including the fundamental notes. The integral multiple of fundamental notes, including the fundamental notes. When we mean integral multiple, we mean there is no decimal. All things there are integers. Just like 1, 2, 3, 4, 5. These are integrals. So we said for harmonics we have 1F0, 2F0, 3F0 to infinity. Because why do we have 1F0 there? 1F0 is the fundamental note, so it's included. So integral multiples of fundamental notes, including the fundamental note, is harmonics. While we'll have the third group, which we call the overtones. I always ask people to learn it from the name, overtones. That means after fundamental notes, the rest follows. Overtones are integral multiples of fundamental notes, excluding the fundamental notes. Where we'll have, this time around, 1F0 will not be there. Rather, what do we have? 2F0, 3F0, 4F0 to infinity. But 1F0 will not be there. Why? Because it's the integral multiple of fundamental notes, but excluding the fundamental note itself. So 1F0 is not included. But in harmonics, it is the integral multiple of fundamental notes, including the fundamental notes. So there we have 1F0. So now we move into the properties of musical notes or characteristics of sound. Now we talk about the characteristics of sound. The first character of sound is the pitch. If you are an organist or you've played an electronic musical equipment, you'll notice that when you tap your left hand side, it gives you a sound, bum 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 bum. While when you tap the other side, it gives you something like tie tie tie. what is creating the difference? That is a character known as pitch. This is the characteristics of sound. Pitch now is a characteristic of sound that enables us to differentiate a high note from a low note. Whenever we are able to differentiate that this one is high and this is low, maybe the same note, for those of you in music, your do, re, mi, is the same do, but this one now is high and this one is low. That character that enables us to differentiate that is what we call the pitch. The second one is what we call the loudness. But before I go into loudness, I also want you to understand that even though that pitch enables us to differentiate high note from low note, it still depends on frequency. Pitch depends on frequency. When JAMB asks you a question like this, which of the following does pitch depend on? The answer is frequency. Or which of the following depends on frequency? The answer is pitch. Now we come over to loudness. Loudness is the magnitude of sensation reaching the ear from the source of the sound. We have some very loud, we have some very low. Now, loudness depends on, first, intensity. It depends on intensity. Secondly, it depends on the square of amplitude of the sound. And the final one, it depends on the mass of the air column enclosed. When you speak, there is mass of an air column you enclosed. That particular thing is what loudness depends on. Three of them. One, intensity. Two, amplitude square. I did not say square root of amplitude. I said amplitude square, or square of amplitude. Now, mass of air enclosed. Now we have the last property there, which we call the quality. Another name for quality is tone, while some others call it timbre. Now this quality or tone, we can say, is the property or character that enables us to differentiate two notes that have the same pitch, the same loudness, but are produced from different musical instruments. This one is produced maybe from a guitar, while this one is produced from a drum. Two of them, they have the same pitch, they have the same loudness, but this time from different musical instruments. And quality depends on overtones. I said they depend on overtones. Remember, the first one, pitch, depends on frequency generally. Loudness depends on intensity, amplitude square, mass of the air enclosed, while quality depends on overtones. That is where we'll call it the end for waves. The next time we'll move over to a new book of physics known as electromagnetism. Thank you.